MBC HUE12 Sensor. Manual. Chapter 1. Product Overview. MBC HUE12 is a professional-grade multi-target vision sensor designed for high-level robotics competitions. It can simultaneously track and return real-time data for up to 12 independent targets, S1 S12. Each slot can be independently configured with its own coordinates and color parameters, greatly enhancing competition flexibility and strategy design. The update rate is 25 frames per second, approximately every 40 milliseconds. It is recommended to observe for at least 0.1 seconds after the robot stops to ensure stable readings. Especially suitable for WRO Advanced category and various international robotics competitions. Chapter 2. Hardware Specifications. Main Controller, ESP32cm. Lens Angle, 68 degrees 120 degrees / 160 degrees. Display, 160 by 128 TFT LCD. Dimensions, 52 mm x 56 mm x approximate 20 mm. Actual height varies depending on lens type. Chapter 3. Camera Viewing Angle Selection. Includes 68 degrees and 120 degrees lenses. 160 degrees lens must be purchased separately. It is recommended to start with the 68 degrees lens for precise detection. Use 68 degrees for longer distances for better stability. Use 120 degrees for wider coverage. Use 160 degrees for ultra-wide view and recalibrate to avoid edge distortion effects. Chapter 4. LEGO Installation Recommendations. Recommended camera height is 12 to 20 centimeters. Recommended mounting angle is greater than 45 degrees. Use at least 2 Technic beams for mounting. Avoid single point or single axle mounting. The sensor must be firmly secured without vibration. Vibration may cause motion blur and misdetection. Chapter 5. Port. Spike. Requires Pybrix beta version. Hub firmware update required. No manual port configuration required. Can connect to any port A/B/C/D/E/F. The hub automatically detects and initializes the device. F3. Manual configuration required for sensor port 1 to 4. Program setting must match physical connection. Chapter 6. System Operation Procedure. Default mode after power on is run mode. Active tracking frames are displayed. Press the right switch downward, enter, to enter menu. The right switch supports left, right and downward press. Chapter 7. Color Configuration Procedure, S1 S12. Each slot is independently configured. Set X sets horizontal center position. Set Y sets vertical center position. TOL adjusts color tolerance. Matching areas are highlighted in bright green, 0x07E0. Adjust until only the target object is covered. Repeat the above steps 11 times. Chapter 8. Camera Parameter Settings. Brightness. Adjusts overall image brightness, -2+2. Higher values increase image brightness, suitable for low-light environments. Contrast. Adjusts image contrast, -2+2. Higher contrast enhances color boundaries but excessive values may reduce detail. Saturation. Adjusts color saturation, -2+2. Higher values make colors more vivid, while lower values make them appear grayish. Exposure. Adjusts exposure compensation, -2+2, to improve detection stability in overly bright or dark environments. Flash LED. Turns the fill light on or OFF, suitable for low light or shadow-heavy competition environments. V-flip/H mirror. Vertically flips or horizontally mirrors the image to adapt to different mounting orientations and prevent inverted display. AWB. Auto white balance on/off. Automatically adjusts color temperature to maintain stable color detection. After completing all settings, you can begin testing whether the parameters are correct. When the camera successfully detects the target, the screen will display the corresponding value and a square frame. The square frame indicates that the slot's detection and data reading are functioning correctly. If the frame does not appear or the values are abnormal, please readjust the coordinates or tolerance settings. Chapter 9. Data Return Specifications. If you use the original Spike version, camera data can only be read using Python. Before getting started, please update your hub to the Pybrix beta version. After updating to the beta version, the programs you previously used in the official version will not be affected. You can directly import your existing programs into the beta version and continue using them. Therefore, you can confidently update and use the beta version. If you are unsure how to update your hub to the beta version, you can refer to the tutorials available on the official Pybrix website. The Pybrix website provides complete update instructions and guidance. Friendly reminder, before making any changes to your program, please save a new copy and create a backup. This helps prevent accidental changes that could result in losing your original program. It is recommended to develop the habit of backing up before every modification. In the Spike Pybrix environment, there are Python and block versions. It can also be divided into basic and multitask modes. The basic version cannot execute multiple tasks simultaneously. The multitask version allows multiple tasks to run at the same time. In this video demonstration, we are using the Pybrix multitask version as an example. On the screen you can see a white input field at the back of the programming block. This field is used to enter the slot number. By entering the corresponding slot number, you can retrieve the visual parameters configured for that slot. The system will return the corresponding HUE and STA values for that slot. The HUE value ranges from 0 to 255. STA represents the average saturation of the detected region, with a range of 0 to 255. On the screen, you can see this section of color classification code. Lines starting with hashtag indicate comments. This means those colors are currently not enabled for detection. Only the lines without hashtag are actively used for color detection. For example, the currently enabled colors are white, yellow, green, and blue. When HUE equals 255, it means no target is detected, so it returns none. If none of the conditions match, it returns NO. These HUE value ranges can be adjusted manually. You can modify each color range based on the actual hue values measured on site. It is recommended to observe the detected HUE values first, then define appropriate color intervals. Different lighting conditions and surface reflections may affect hue ranges. Therefore, please fine-tune the color ranges according to the actual competition environment. Then define appropriate color intervals. Next, on the screen you can see that we are using the HUE value for classification. Based on different value ranges, we convert them into corresponding letter codes. For example, specific value ranges are converted into codes such as YEL, GRN, and BLUE. These letter codes are simply classification labels within the program. Users can customize the slot codes according to their own needs. You may change the codes to your preferred abbreviations or full names. The key is to define your own color detection logic based on the HUE ranges. The EV3 version provides dedicated graphical programming blocks for direct use. The video will demonstrate how to import the dedicated MBC Vision Sensor blocks into your existing EV3 program. Please follow the steps shown in the video carefully. After completing the import, reopen your EV3 program. In the yellow block category at the bottom of the program interface, locate the dedicated MBC Vision Sensor blocks. These blocks can then be used to read and control the vision sensor data. The parameter settings in the blocks follow the same logic as the Pybrix reading method. In other words, once you select a slot, it will correspond to the value of that specific slot. Different slots represent different configured targets. Chapter 10, Developer Information. This product is designed and developed based on the ESP32 architecture. Users may write custom programs and reprogram the hardware according to their needs. The original firmware source code of HUE12 is not publicly provided. Any malfunction caused by self-modifying or flashing firmware is not covered under warranty. Chapter 11, Product Warranty Terms. All products undergo multiple functional tests and quality inspections before shipment. This product includes a 6-month limited warranty. The warranty period begins on the date the buyer receives the product. For non-human caused defects under normal use, the company covers all round-trip shipping and repair costs. Damage caused by human factors is not covered under warranty. If repair is required due to human factors, the buyer must cover round-trip shipping and repair costs. The company reserves the final right of warranty and responsibility determination. Thank you for watching this complete tutorial of the MBC HUE12 Vision Sensor. We hope this introduction helps you apply it more smoothly in competitions and project development. The example programs used in this video can be downloaded through the sample program option in the store link below. Please select the corresponding version according to the instructions. If you have any questions, feel free to contact us at any time. Stay connected with us for more practical tips and future updates. We wish you stable performance and excellent results in your competitions. I'm Lao Shao, see you next time.